Your monolith started simple: one codebase, one database, one deployment. But now, 50 engineers stepping on each other's code. Deploy once a week if you're lucky. Scale the entire application just because one service needs more memory. Sound familiar? But here's the thing: not every monolith needs to die. A well-structured monolith with 15 engineers, often simpler, cheaper, and more reliable than distributed chaos. Migrate when you have real problems. Teams can't deploy independently. You're scaling everything for one component's needs, or different parts need different reliability guarantees. So how do you migrate without breaking everything? The strangler fig pattern, named after a tree that grows around its host and gradually replaces it. Here's how it works. First, place a proxy in front of your monolith. All traffic flows through this gateway. Then identify a bounded context, a self-contained business domain that changes frequently. Build the new service alongside the monolith, not instead of it. But here's where most teams die: data migration. The iron rule is simple. Each service owns its data completely. No shared databases. Period. If two services need the same data, one owns it and exposes it through APIs or events. This means foreign keys across services don't exist. Replace them with service-level references. Store the ID. Call the owning service when you need the data. During migration, you need both systems running. Change data. Capture solves this. Tools like Debaysium stream changes from your monolith's database to the new service in real time. You dual write during transition, then switch reads to the new service, then finally stop writes to the old table. It's like building a bridge while people walk across it. Here's a trap that kills migration: shared libraries. Your monolith has common libraries with business logic, data models, and utilities mixed together. Extract services naively, and they all pull in this library. You've just created hidden coupling. The fix: split the library ruthlessly. Pure utilities like string formatting can stay shared. Business logic and data models must be duplicated into each service. Accept the duplication. It's the price of independence. In your monolith, everything was consistent. Update a user's email and it's immediately reflected everywhere. Microservices break this fantasy. You get eventual consistency. The system becomes consistent over time, but might have temporary inconsistencies. A user updates their profile, but the analytics service shows old data for 30 seconds. Designed for this. Make operations idempotent. Build compensation transactions. The trade-off is independence for perfect consistency. Reality check on timelines. 100,000 lines of code with 20 engineers? Your first service takes 3 to 6 months. Full migration, 12 to 24 months. 500,000 lines with 50 engineers. First service, 6 to 12 months. Full migration, 2 to 5 years. These assume you already have CI/CD, containers, and observability. If not, add another 6 months for platform readiness. Most migrations fail in predictable ways. Big bang rewrites, rewriting everything at once instead of strangling incrementally. Distributed monoliths, services that still share databases and deploy together. Ignoring operational costs. Each service needs its own CI/CD pipeline, monitoring, and on-call rotation. The successful migrations start with 2 to 3 services, not 20. The strangler fig isn't just a migration pattern, it's a philosophy. Grow the new system around the old. Extract domain boundaries, not technical layers. Own your data completely. Accept eventual consistency. Start small, move incrementally, and resist the urge to decompose everything at once. Your monolith took years to build. Give the migration the time it deserves.